Okay, we will wait 1 or 2 minutes more. So some of the students like watching on the YouTube live streaming, and some of the students are joining the Google Meet. So we just wait 1 or 2 minutes and we will start.
Sure, that's fine.
Okay, so very good evening, everyone. So I'm Anand Kumar, a secretary of blockchain at IIT BHILAI. So this is the 3-month online summer blockchain bootcamp. So we already covered blockchain with the Partikesh Patel from the Polygon, blockchain engineer from the Polygon lab, and also we already covered the Bitcoin fundamental and the fintech aspect of Bitcoin, and also we already covered the Ethereum fundamental protocol. So now this is the season 5. So we will uh, learn about the smart contract, and we have an expert, David from the Nigeria, and he is a smart contract auditor and the developer, and he is also the founder of company Google Audit. So this is just a quick introduction of me. So yeah, welcome David. So just please introduce us. So now we can start. Hello, David.
Okay, yeah. Give me a sec. I'm trying to just come up with my slides.
Yeah, sure.
Okay, so before my slide comes up, Alan, please just check up your WhatsApp. So, hi guys. Please, am I audible?
Yes, yes.
Okay. I'll just turn on my camera some minutes so that then just kind of see our faces. Then we move on. Um, hi, hi guys. So I'm David. So just like what Anand said, I'm David. I'm a smart contract developer and auditor. Yeah, that's like a very quick introduction about myself. Also, I've been trying to train a lot of developers and auditors in the space. And yeah, you're here today also just to look into smart contracts and some key topics in smart contract development. Um, Yeah. So before I start, I like to do some of these things, right? So I would just want two, three persons to just tell me, maybe just say your name and just give me like an introduction or no, an expectation you have in mind for this class today. Yeah. I just have like two or three persons. Anybody?
Yeah, hello. So I'm Uzochukwu, and basically I'm expecting today to learn something new. I have no idea about. I have a little idea about a smart contract, so I want to dive deeper in it.
Awesome. Any other person? Anybody?
We are expecting to like learn about how like what is exactly a smart contract, why do we need, I don't know, like some of the students don't know why we need a smart contract, what is like how it's connected to blockchain, why this is immutable, and all those things, what is the like NFTs, like everyone heard about NFT but they don't know how exactly look like NFT, what is the behind the scene of NFT.
Awesome. Awesome. Yeah.
And
So
also we are expecting to learn about some decentralized finance, how it is better than traditional finance.
awesome. Yeah. Um, so yep. So we'll just start by asking also another question, right? I believe you've heard about smart contracts, smart contracts, smart contracts. Just by the word literally, like smart and contract, can anybody just tell me what they feel that will look like, what it means? like from their own understanding, just from the word smart and contract. These are two words, right? So what do you understand by it? But by that, by this term, smart contract? Anybody?
So I think this is smart contract enough smart to understand what is the agreement between two parties.
Okay, just not to waste most of our time. So I like to start this by first saying most of the things we want to learn, there is always sometimes an example that is out there already, maybe we are familiar with, right? That we can always give scenarios with. So for talking about smart contracts, um, I believe most of us have got into agreements, right, with maybe our friends or a company, or you've actually gone into an agreement, and most often you write this agreement through the help of a lawyer or something of that nature. You write out these agreements on a piece of a paper, and either the two parties agree on those terms and conditions of those on that piece of paper, right? So that's like a contract, right? That's like a contract. So, but in these terms here, one of the things also we want to see as smart contract is that it's also in something of that nature. But at this point here now, smart contract is now smart because you want to see this, that it does this automatically, right? It has now technology in it. So go to the next slide. So, so smart contracts are firstly contracts that are softwares. The basic definition of a smart contract is a software, right, that is being written in a programming language, right, and is deployed on the blockchain, right, and it really will do what it is said to. Firstly, so for a smart contract, a self-executing contract with predefined rules and conditions, right? So if you have said, okay, this contract or this agreement, right, in our own layman terms, will be this agreement is said to pay Anand $1,000 in the next 5 years. This agreement has been written down, right? A lawyer has signed it. Other parties have signed it. There is nothing that will come on this earth that will break that agreement. Like literally, we know that, right? If we have written out an agreement like that on a piece of paper with the help of a lawyer, right? So the same scenario also happened when we talk about smart contracts. So, but now this smart contract we are talking about here now is not like the one we know we write on a piece of paper. This one, when we are writing this smart contract using code, right? When I mean code, using a programming language. You can write a smart contract using a programming language called Solidity, which is the most common. You can write a smart contract using a programming language called JavaScript. You can write it using Rust. You can write it using Python, right? So there are really a couple of ways you could write your smart contract or write your agreement, right? So, but this agreement now is self-executing. So, for instance, I wrote an agreement, or let me use the right word, means I wrote a smart contract, right? And on the smart contract, in the terms or condition of that smart contract, I want that smart contract to pay Anand $500 after he has done a tax, right? So maybe the tax I want him to do is to click a button after 3 minutes, right? So if Anand clicks a button after 3 minutes, automatically he receives that $500, which I have actually written in the code, and it's agreed that this is what the code will do, right? So it's self-executing. So immediately Anand just clicks that button, $500 will be sent to him, right? just as the agreement is set to do. So it's self-executing and it's predefined. So because before the action happened, right, I've defined what will happen. So I've written out the code, I've written out the logic, and I have said, okay, this is what I want to happen. This is what I don't want to happen. If this happens, this should happen. Basically, I've written out the logic, right? So I believe most of us here are also like coming from a tech perspective where we understand when I talk about logic, right? When you try to write logic, you start writing your pseudocodes, right? You have an algorithm, right? So you've written out all of this logic and you've written out your agreement. So it's self-executing, it's predefined rules and conditions. So also smart contract automates contract execution and enforcement using computer code, just like what I just said, right? You wrote this code, you wrote this smart contract using a programming language, right? And it will surely just do what it is said to do. And the way the technology is being designed, right, using technology like blockchain, which we'll be talking a little bit more on, it will automate that process, right? You don't need to come and take the money and give it to Anand maybe manually, right? It will just automate the process automatically. Anand gets the money in his predefined address or in that wallet he wants to get. Also, smart contract is key, immutable. That's one of the key features of smart contract. It's immutable, right? So what do I mean by immutability, right? It's you can't change it after you have developed or deployed it. You can't change the agreement after you have signed it. So what do I mean by signing it? So for instance, when you talk about the normal thing we know, which is signing of agreement with the help of a lawyer, right? The two parties that are trying to agree on something will have their signature on that paper. After the signature, right, on that paper, it's like it's a closed deal. Nobody comes. You can't change the rules or the regulation, the conditions on that agreement anymore. I'm talking about when we try to sign agreements with through the help of lawyers, right? So similar things like that also happen when we talk about smart contracts. It's immutable. After you have written out your code, whether in any programming language, you've written out your code and you have deployed it, right? So at that point, let's see deployment as signing off that agreement when we are doing that through the help of a lawyer, right? So after you have signed, that you've deployed it, that's the right word to use here. After you've deployed your smart contract, maybe in the Web 2 terms, you want to see deployment as you have built the you've built the system and now it's mainnet, it's live. You can't go back and say, no, I want to change 5 to 10. Or I just want to change, there was also a full stop. I want to remove the I forgot to put a full stop. You can't do that after deployment, right? So smart contract is immutable and it will always do what it is set to do, right? Advantages of smart contract. So you have transparency, right? You have security, you have cost savings, right? So when you talk about transparency, because of this smart contract, you're building this smart contract on the blockchain. So I believe you guys have gone through the topic of what the blockchain is and etc, right? So you're building this smart contract on the blockchain, and the type of blockchain where you're building it most often is let's take for instance a public blockchain. So a public blockchain is one where you could see every transaction, like it's public to everybody that is connected to that network, right? So you could see all the transactions, and most often you could also see the code, right? So that's most of the times when you deploy your smart contract, you verify it. Always, anybody can go and see the code. Like you could see the code. That's one part of transparency. Another part of transparency is once it has been agreed, right? There is no back door to for somebody to now come in. As long as everybody understands the terms and conditions. And when I mean terms and conditions here, I mean the code itself, right? So there's that transparency there that it's clear, the logic is clear to everybody. You could see what it's set to do, right? There is no backdoor, there is no someone trying to get into or change something out of the system, right? So that transparency is very, very open, and it's open. It's open to the system. So also we have security. It's very secured, right? So because why one of the main things that makes it so secured is the technology itself. That's the blockchain, right? So you wrote your smart contracts in, let's say, Solidity, right? And now you deployed it. So the mechanism that is used to deploy these things, one of the interesting mechanism or technology that is used is cryptography, right? Where it hashes all of these things, and it uses a hashing function, right? Where it's just one way. You can't actually reverse those hashing function back to get the original thing. So the security here first, I'm talking from a different perspective of what smart contract security gives to you, is that through the use of blockchain, right? Someone can't really change something without a footprint, right? When you change something, maybe you have a function that needs to change a variable, right? I believe you understand what I'm saying. You have a function that needs to change a variable. When that function is being called, right, you can always know who actually called the function, right? Because the footprint is there. So the security is there. And also you can actually put some security guards around the logic of your smart contract, right? So that's also one aspect of security, right? Where what the smart contracts have, right? So I could just go on and on.
David, I have just a quick question. So
Yep.
let's say any auditor find the security in the smart contracts. So because the smart contracts is immutable, so how can I change the logic code of my smart contract? So is it possible in any way?
Yeah, so that's a very, very nice question. So one of the things I like doing during quick workshops and classes like this, because we have limited time. Yeah, we might stay up to like an hour or two here, right? So, but we have limited time to really, and there's a lot of information to really push out. So, but first, just to go straight to your question, I just don't want to make someone feel like I'm contradicting myself, because I initially said smart contracts are immutable. And now I'm about to say you can actually change something on smart contracts, right? So I hope nobody will get me wrong or misunderstand me. So, but let me give more light to that, right? So yeah, smart contracts are immutable, right? Immutability comes when you it comes
Immutability in
on
the
the
terms
smart
of
contract when you have,
I think
sorry, come again.
immutables means the code that we have written is not changeable. But we can anyhow we can change the logic of the contract, right?
Yes, thank you. That's what it is. So it comes when you have written out your code, right? That's where immutability comes in play. So, but when deploying, right, there's now a system in which you can use that helps you to now change some logic, right? Change some logic. So let's take so just a very quick explanation to that, because I'm trying not to really make it, and because it's really quite um, ambiguous if I'm trying to explain it. So a very quick explanation is there's what we call upgradable contracts, right? Upgradability, where you can actually upgrade the smart contract itself. And in upgrading the smart contract, it means you are not interacting, you are not changing like the logic literally on the code you have written, but rather you are removing the deployed code and changing it with a new code that has been fixed, right? So that's like what it is. So maybe in another class, I might just show you that part where you get to upgrade a smart contract, where you see how we'll be able to change a code base into a new code base, but it's still having the same states of its original of its original state, right? So, but I hope that gives a more clarity of what it means by immutability and how we could change like smart contracts when we talk about upgradability. I hope that was like
Yes.
clear enough.
Yeah.
Okay. So let's talk about some basic use cases of smart contracts, right? So there are a lot of use cases. There's just a lot of use cases of smart contracts. A lot. You can think of it in different parts of life, like how you could use this technology, how you could use this skill to really solve problems. So one interesting part of, or one most use case of this smart contract is in the finance service, right? Before now, I think why blockchain was really like mainstream is because of the finance use case of blockchain, right? Which is Bitcoin. So a lot of people have this misconception that Bitcoin is blockchain, which is not, right? Bitcoin is just one use case of the blockchain. In fact, I would not say it's just one. It's not up to you. It's not just up to one. It's just this use case that is super mainstream that a lot of people know. That's why it looks like it's the blockchain itself. No. So Bitcoin is a use case of the blockchain. So what's the initial part of the Bitcoin, right? Bitcoin is just to be able to help us send like maybe make cross-border payments using the blockchain technology, right? That I can actually send you some funds, right, which is called coin, that can be valuable or that is valuable, and you can actually sell it to get back maybe your fiat, right? So in one really use case of the smart contract is in the finance world, where you can use the blockchain or the smart contract to build financial services, right, that will help in transaction. So for instance, we in the finance part, we could look into our normal banking system, right? Our normal banking system where you need to wait. I believe, okay, I will just use Nigeria. So for you to use the normal banking system to send funds from Nigeria to another country, sometimes it would take a day, 2 days, depending on the bank you're using and depending on the service. But coming down to the blockchain, coming down to using smart contracts, right? Using smart contract technology, maybe you built what they call a decentralized exchange, right? Where you can actually send funds in less than some seconds. Right, in less than some seconds, you can send some funds from one country to another. In less than seconds, I just need to now have your wallet, and in seconds, I can send you some coin or token to your wallet. In less than seconds, you get it to your wallet, and if you choose to convert that to naira, that's in my country, or you choose to convert that to your own fiat, your own country, that's like fine, and that will now be done, right?
So,
in maybe in that system you've built, right? So that's like one part of it. Yeah. You want to say something?
yeah. So today you will send some cryptocurrency, one of them in this class.
You said?
So today in the demo, you will send some of the cryptocurrency, one of my account, one of us.
Yes. So we'll try and do something of that. So we'll try and see if we have more time. If there's more time, we'll build a token, right? And we'll then deploy it and try to distribute it in anybody that has a wallet, right? So that would be
So
like
very exciting. So
sending.
everybody like ready with your public wallets. So you will get some tokens.
Yeah, so everybody get ready with your public wallet. We'll be creating a token and we'll be sharing. But only that the token does not have value, and we're doing that on the testnet. So yeah, that's what we'll do. So so yeah, that's the so that's like some advantage and use cases of a smart contract. Also, to put right, there are some components, like three components you want to understand in smart contracts, like three key components: the agreement, that's the logic, right? The code, that's the code itself, right? The code that is written itself, maybe in any programming language. Then also you want to talk about the blockchain, right? That's now where the code will be deployed on. So these three components are really what uh, gives a better understanding, or and a better basic understanding of what uh, the working principle of a smart contract, right? You have the agreement, that's the logic, like what are we agreeing on, what will be the logic, what will be the logic be on, right? Then you have the code, right? You're writing the smart contract in a code and using a programming language. Then you also have the blockchain, right? Which is now, you now decide what blockchain am I building this smart contract on? Am I building on a public blockchain, or on a private blockchain, or on a consortium blockchain, etc. Right? So most often we'll be looking more into a public blockchain and trying to focus more on Ethereum blockchain. I believe we have most of you guys have covered that topic in the former class, where you talk about type of blockchain. You have public, private, um, consortium blockchain. And when you talk about public blockchain, you don't talk about Ethereum. You talk about Avalanche, right? etc. Right? So you want to see those as public blockchain. And why those are public blockchains is that the ledger, right? That's the blockchain itself is public to anybody that is connected to that network, right? So we will not go into that in more details. So we're more looking into Ethereum blockchain, right? Because that's like the most common, and yeah, that's the most common public blockchain we have in the space now. So still talking about smart contracts, right? So in writing smart contracts, we have different programming language you can use to write smart contracts. One most used programming language is Solidity, right? One most used programming language is Solidity. And I believe, so let me just get also like some feedback from you guys. I believe some of us understand the basics of, let's say, JavaScript or programming languages. So I want to just, you could write in the comments, like, what programming language do you know? Like anybody, you could just maybe write in the comments. I want to just have a feeling of what programming language anybody knows. Like just, yeah, in the comments. Yeah, C++, interesting. Yeah, anybody else? C++, Python, JavaScript, awesome. Anybody? Okay. C, JavaScript, Python. Interesting. Awesome. Awesome. That's cool. So yeah, very, very interesting that most of us understand C, C++, JavaScript, Python, right? Right. So this programming language that is mostly used in the public blockchain, which is called Solidity, is more like also in the family of C programming language, which is OOP, right? Right. So that's like the family of Solidity. So we'll be looking into some so let me go this. So yeah, so I'll be using Solidity by example, and I'll be sharing this link with you guys here very quickly also, where you can just have a quick run through of how Solidity works, right? So let's look into like a very, very basic primitive data type, right, in Solidity. So we have Boolean, we have uint, we have int, we have address, right? These are primitive data types in Solidity. And yeah, so let us look into this code very quickly, and I will just do some quick explanation on it. So I guess also you guys understand Remix. So I'll be using Remix to illustrate these basic data types you have in Solidity, right? If you don't know what Remix is an IDE. It's an online IDE where you can also run Solidity codes on, right? You can actually deploy smart contracts using this IDE, right? So I'll be using this IDE for that illustration. I guess I'm having some network issue now. Okay, so I'll just create a file here. Okay, is my screen visible?
Yes.
Okay, thank you. Will you need me to increase the font?
It will like better if you just increase. Yeah.
So
Yeah, now it's okay.
okay, so let me just explain what we have in this code base, right? So firstly, let's look into smart contract, right? Now literally, this is what you can see here on my screen is a smart contract. So in writing smart contracts, as a C programming student, right, you understand objects, right? I believe you understand when I say objects, right? So in writing, or you understand object, you understand class, right? So in writing smart contracts, you want to see the whole logic of that smart contract into what you see this into an object, right? You want to see that an object, and this object starts from here, right? So this object starts from here. So firstly, in writing a smart contract, you create a file, and you have the extension of that file name with .sol, right? And in the file, you start by declaring the version of the compiler you want to use, right? And in doing so, this is how you declare this, right? Pragma Solidity, then the version you want to use, right? So after that, the next thing you want to have is the code base itself, where it looks like an object, which you have to declare this. First, you use the word contracts, right? Use the word contract, then the name of the contract. So in C, you want to see it as like the name of the object, right? So you use the keyword contract, then the name of the contract. And that's so inside. So after that, you have a curly braces. So in between these curly braces, that is where you have all your logic, right? That's where you have all the logic, right? So in this logic, this is where now you'll be having all of the primitive data types, your functions, your variables, and etc. So Solidity is not far from what we know in programming language. I believe every programming language also follow like a kind of almost similar system architectural way, in the sense, when I mean in that point is in the sense that most programming language has the way they write data types, right? But at least there's a keyword that is general to them, which is data types, right? You mostly also have for some programming language where you have functions, right? You also have functions here. You also have objects. You also have like an object kind of in Solidity, right? So if you understand any programming language, right, also take that kind of scenarios also here. So maybe in JavaScript, right, you have Boolean data type, right? So you also have Boolean data type in Solidity, right? And Solidity also is like you need to write out, like specifically write out the visibility you want to have in that on that function or data type, right? By default, it is actually not public, right? By default, it is not public. It is by default, it is not public, it is private, right? You want, so most times you need to now write out the visibility. And what I mean by visibility, what do we call it in OOP? When you want to have a visibility on your C, maybe you're trying to write a function and you need to put a visibility. There is a keyword that is being used to address that. Can anybody help me with that? Anyone?
Could you repeat your question?
Please, am I audible?
Yes, you're audible.
Yeah, so I was kind of asking, when you're trying to write maybe a function and you want to add like a visibility, there's a keyword in object-oriented programming that tells like describe that concept. So for instance, I believe we have inheritance C, right? I think there are 4 core concepts in object-oriented programming, right? So I think one of the concepts also explains that. So, but let me just move forward. So we have a Boolean data type, and the way you declare a Boolean data type is by using the word bool. Public here shows the visibility of this variable, right? So by declaring the keyword bool, and then the name, that's variable name of this variable you're trying to declare here. So you have the variable name as bool, and at this point now we are initializing it with so Boolean is always true or false, right? So you are initializing it with true. So that's like so at this point now you have created you have declared and initialized a variable, right? You have declared and initialized a variable. So you can always now refer bool, and always you get true. So also very quickly, when you have a public keyword here, right? It now gives this variable becomes a getter function. By default, once you have a public visibility on a variable, the variable becomes a getter function. What I mean by a getter function, you can call this variable. This variable becomes more like a function. So you can call the variable, and it returns to you like outside of the contract, and it returns to you the value that was stored or that was initialized with the variable. So we have Boolean, that's one. We also have the uint and int, right? So most often in JavaScript, so maybe I'll use JavaScript also to illustrate or to compare a little with Solidity. So also most often in JavaScript we have integer, right? We have strings, we have Boolean, we have etc. Right? So in Solidity, right, you basically need to really specify. So it's not like JavaScript where I will just have length, const, right? And that's like under the hood, solid JavaScript will be able to help me to translate that data type I'm trying to use, right? So, but in Solidity, you need to type out or you need to really specify the data type you want to use. It's just like in C, where you need to manage your memory, right? In C also, you need to specify the memory or the data type you are basically using. So, for instance, we have the uint and we have the int. So for uint stands for unsigned integer, meaning non-negative integers, right? Uint stands for unsigned integers, meaning these are non-negative integers. And for int, this int stands for unsigned, and int can actually take negative and positive integers, right? So, but for uint can't take a negative integer, rather only positive. So what do we mean by taking negative or positive? So first, how do we declare a uint? How do we declare a uint? So we have the highest value for uint, right? So the highest value in Solidity that an integer variable can take is 256 raised to the power of 1. Sorry, raised to the power of minus 1. Sorry, I guess I missed that part.
256 bit.
Yes.
The value is unit 256 is 2 to the power of 256 minus 1.
Yes, so that's the length, or that's the that's the length. Would I call it length?
256
Yeah,
bit length.
that's like the length of what a variable can take in Solidity, right? So you also have, so if you know your variable will need to take a number or an integer that is greater than this limit, which is 256 minus 1, you now start having some issues because you are exceeding that that standard, right? So you now start having some security issues where you now talk about overflow and underflow if now that becomes the case, right? So, but just understand that in Solidity, the highest length or integer variable can take is 256 minus 1, right? So when you do that, you see how big the value is. So you can also have uint 8, right? You can also have uint 8, which is okay, let me just use what we have here, which is a range from 0 to 2 times base power of 8 minus 1, right?
Yes.
So you can also see the range of that of uint 8. That's how many what's the range it can carry, right? So you also have uint 16. The same thing goes there. You also have uint uint 128, right? You can also have that type of uint, right? So how do you declare a uint in Solidity? You use the keyword uint and specify which type of range you want to use, right? Then also followed by, you can have to have the public keyword or not, right? So when you attach a public keyword, just like what I mentioned, it becomes like a getter function, and then you declare the variable name, right? So this becomes the variable name. And at the same time, for this variable here, we are basically initializing it at the same time as we are declaring it, right? We're initializing it and as we are declaring it. So that's how you get to declare a unit. And just as I said, units can only take positive value. So for also, when you don't declare the type of or the range on the data type, right? Maybe you just have units. By default, right? The default state of units is uh,
0.
256 minus 1. That's the default state,
Yes.
right? So once you don't declare like, oh, I want this variable to have a range of unit 8, you just declare unit. By default, you are saying it should take 256 minus 1. So maybe in another class, we will talk about how these units affect your programming. If you don't specify, how does it affect it, right? How does it affect memory? How does it affect storage? Because all of this also affects your storage and etc, right? So maybe in another topic or some other time, we could also talk on that aspect. So, but there are things like that also you can check on, and I can also share resources, right? Solidity documentation is also one place where you could check and read more on. So, Solidity, let me just look for that. If nobody has seen it. Solidity documentation is really too cumbersome, but it's something I feel you should also look out for. So I'll just share the resource that's here. Yeah. Yeah. So we also have ints, right? So just similarly to what we talked about in units. But for int,
Hello. 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 Am I audible? Is David audible? Can you hear?
Currently on silent.
I think he has some Wi-Fi issue.
hello?
Yes. No, we
Yeah,
can
please,
hear you.
sorry, I had a network glitch, so I needed to switch to another network. But can you hear me now?
Yeah. Yes. Not sound good.
Okay, awesome. Is my screen also visible?
Yes. Your screen is also
Okay,
visible to
awesome.
us.
Okay, awesome. So in int, we also have similar to what I explained in units, where we have the int 8, int 128, int 256, right? So, but in int, what the difference between int and unit, right? In int, it's that int can take positive and negative value. So in int, you can have -5, -7, -8, right? Int can actually handle that. But when you declare or initialize a uint with a negative value, that's already, in fact, Solidity will give you an error, right? Because that will be like a syntax error, right? Because the compiler, right, will not be able to understand that syntax, because the uint does not take in negative value. It only takes in positive values, right? So positive values are like 1, 0, 1, 2, 3, thereabout, right? The negative values, the other line of the um, the number line, right? So in int, you could have plus, you could have 5, 10, 7, 2 positive value in, and also you could also have -5, -7, -6, etc. So how do you declare a int, right? The keyword int, that's int, then you also specify the range of the int you want, and also you can decide to have a visibility. If you have a public visibility, it means it will become a getter function, right? So, but if you decide not to have, you can just have it like this. And the variable name, right? So you could have the variable name as anything you want, right? The variable names, like, you can decide to just call it like this. Now is called I8, right? You can decide to say it should be go, right? Anything, right? It should just be anything you decide to have the variable name. Then at this point, we're also initializing it, right? We're initializing this variable to an integer, right? -1, right? Because so it's compatible to take in negative value. So the same thing goes for a positive value. So that's that for integers in Solidity. That's also one part of the primitive data type we have in Solidity. Another one we have also is the address, right? Is the address.
So like how the address took the like data type. Is they different from like something data type in C?
Yeah. So before I go into the address, I want to take up some few questions before I go to the address, right? So let me just take questions for now. Anybody with questions, you can type your questions, or you want to speak out, you can actually speak out. You can raise up your hand and somebody will just call upon you. Questions. So maybe I'll just use the next 5 minutes. I'll use 5 minutes for questions and answer. Then I will just take up the next little. By in 30 minutes time, we'll be done with class. So, but let's take questions for now.
Guys, if anyone have any question, just drop in chat box or you can ask directly.
Hello.
Yeah, I think no one has any questions, so like we can go ahead and like we can just show a demo of like how we can deploy any contract.
Okay. I really wanted to make sure that. So, how is this? What I've said so far, is it clear? So it's not like I don't like being like myself. I have some feedback from anybody. Since there is no question.
Yeah, it's clear.
Yeah. Anybody wants to say something?
We are familiar with coding, obviously, so it's not that much tough.
You are what? I didn't get you, please.
Ujjwal, could you repeat again what you said?
Yeah, I said
Yeah,
I'm
I want.
actually we are familiar with coding, so it's not actually that tough for us. So we are understanding.
Oh, okay. I guess okay. You're familiar with all of these things. So maybe if that be the case, then let me just move to the next few things because of our time. Then, if you're familiar with um, okay. So yeah, so you can also read more on Solidity data types from the Solidity documentation and some other resources. I think I'll also share some I have with Anand, and Anand will share with um, every other person, right?
Yeah, sure. I
Um,
will share with everyone.
so, so very quickly, let me see the next. Okay, so at this point also, I would like to deploy. Let me see, what do I have next? Okay. So I will be deploying a very simple, very quick smart contract, right? I'll deploy a very quick smart contract. And what smart contract am I trying to build, right? So first, I'll be building an ERC20 token. I'll be building a token, right? So in part of this our class, we'll be talking about the difference between a coin and a token, right? So, but because of this aspect, right? Okay, before I even build this token, I would like to talk about coin and token. Then I'll come back to building a token that's demonstrating of demonstration of deploying a smart contract on a testnet, and the smart contract we'll be building will be a token, right? That we'll be building on a blockchain. And what blockchain are we building on? Polygon, maybe Polygon blockchain or Ethereum blockchain. And so when I come down here, I will explain how we go about it. So let's talk a little about currencies, right? Versus native currencies versus tokens. I'm sure a lot of persons have heard about uh, cryptocurrencies, tokens, coins. Yeah, I think those are the commonly used terminology, right?
Yeah,
Right.
and many of them
So
like very confusing between the tokens and the cryptocurrency.
yeah. So I want to know, can anybody give me an what do they understand by apart from Anand? So I want to get every other person's contribution here. So I want to understand what do anybody understand by cryptocurrency? When you hear cryptocurrency, what comes to your mind? And when you hear token, what comes to your mind? Right? So anybody, please.
It is basically a mean of exchange, just like any
You
currency.
said?
It's in the digital format. That's it.
I didn't get that, please.
Yeah, what?
I said, anytime you hear cryptocurrency or tokens, what comes to your mind? What's like the next thing that comes to your mind?
Cryptocurrency are basically th- what means of exchange. Yes, cryptocurrencies are means of exchange, just like any currency, in the digital format.
Okay. So what about tokens?
Tokens, I don't have
Okay.
really an idea about.
Okay. That's nice. So yeah, that's also a very good one. So native cryptocurrencies versus tokens. So why do you even tag these native cryptocurrencies? Right? Tokens are also cryptocurrencies. So what is cryptocurrencies? Right? Just like the word it says, crypto and currency and like currency, right? So um, from the word itself, crypto, that comes from like because I believe that comes from like cryptography. So, but it's cryptography from the aspect or from the concept of blockchain, right? So currency maybe a form of a like what do you call it? a medium which we can maybe exchange values, right? So we can say, okay, the currency today is my laptop. This laptop is a currency, right? I can say, okay, the currency today for my community will be a, a pen. That's the currency. So as long as that currency is agreed, that is used to, it's agreed by that community to be used, right, for payment or for transfer of values. I give you this currency, you give me this. Okay, this is a medium which we can use to like make transactions, right? That becomes a currency. So, well, what do we mean by a native currency in terms or in this context of blockchain? Right? So because we can actually tag this to other things, right? So what do you mean by native cryptocurrency in the context of blockchain, right? What we mean by native cryptocurrency, we are now talking about a blockchain that has its native cryptocurrency. I come again. So when we talk about native cryptocurrency, it's basically a blockchain that has its own native cryptocurrency, right? And one example of it is Bitcoin, right? Bitcoin actually is working under a network blockchain, right? Bitcoin is a cryptocurrency, and let's say, luckily, the name of the blockchain also is Bitcoin, right? So another example is Ethereum, right? So Ethereum is a blockchain, right, which uses the Ethereum virtual machine, right? So it also has its native currency called Ether. So Ether is a native currency of Ethereum. So what you can say, and Ether can also be seen as a coin, but Ether cannot be seen as a token. So these terminologies are mostly used interchangeably because they have slightly differences, right? So Ether is actually a coin, is a native currency of a blockchain. But let's say, for instance, Shiba Inu or Dutch token is not a coin, but rather a token. I believe a lot of us have heard about Dutch token or USDT or USDC. These are tokens because they don't. These tokens don't have their own blockchain. They're actually running on another blockchain, so they are token, not a coin. So it's, yeah. Somebody was trying to ask a question.
Yeah. So is Matic a token or cryptocurrency? Because Matic has own blocks in the Polygon.
So very, very interesting, right? So Matic also is a coin, right? And why do I want to say that, right? Because most often, you notice that, in fact, from the use case of this cryptocurrency, because all of these are cryptocurrency, both token, both coin, right? From the use case itself, you kind of know what I mean when you said, "Oh, this is the block. The coin is a native currency of a blockchain." So, Matic is actually a coin because it's also a native currency of the Polygon blockchain. And one of the use cases of this coin is that they are the currency or the cryptocurrency that is used to pay for gas in those blockchain. Right? So when you want to perform a transaction on Ethereum, you need Ether to pay for gas. You don't need USDC to pay for gas. You don't need USDT or another token to pay for gas. Yeah, we now have systems, right, that you can actually use those tokens to pay for gas. But under the hood, right, when you talk about maybe account abstraction and the likes, where that allows you to use those other tokens to pay for gas, right? So what is happening under the hood is that those tokens are now being converted and are now being converted to the native currency that is then being used to pay for the gas. So literally, you are still using the native currency to pay for the gas. Yeah. So I hope that was clear. Like coin and token.
Yes, yes. Now it's like very clear.
So, what is a token? I've just mentioned is a token is let's so in the Ethereum ecosystem we call them an ERC20 token, right? ERC20, right? So so in layman
The
terms
fungible token, like
is a cryptocurrency that does not have its own blockchain, right? Or is a cryptocurrency that does not is not the native cryptocurrency for its own blockchain, right? So a token can be any other cryptocurrency that um, does not have its own blockchain, right?
yes, yes.
So we have several types of cryptocurrency. I mean, cryptocurrency on tokens, right? A lot. We have a lot of them. When you go to CoinGecko or you go to CoinMarketCap, you see a lot of tokens, right? So most often you find a lot of tokens and you find very little, very small coins because we just have few blockchains that are being built at the moment, right? So maybe out of maybe you find
So how do
hundred
the
of thousands.
tokens work? Like,
Sorry,
how do the tokens work on which blockchain? The ones that already exist?
how do what?
How do the tokens work on which blockchain? Like they are free to choose any blockchain.
I'm trying to. Sorry, please. I didn't get the question. I was.
Yeah, the question of usual is like how the tokens work. Like, can we choose any blockchain to deploy a token, or if the token is already existent, like native cryptocurrency?
Thank you. That was one reason also to incentivize users that okay, I want this user to be able to do X, Y, and Z, and if they're able to do X, Y, and Z, I will give them something. So that thing that I'm trying to give them would be a token, right? So also, I can also one of the use cases for tokens is to also foster cross-border transactions. So, for instance, today we have USDT, which stands as a stable token, right? It's a stable token that is pegged to a dollar, right? One USDT is also equals to $1, even though you have those decimal places from the USDC. Sometimes it goes like 1.1.002 or 1.02 thereabout, right? Sometimes it goes to 9.99999 uh, to a dollar, right? So, but literally we see that as one USDC is equal to a dollar, right? So that's also one use case because it allows cross-border payments that today I can actually receive a $50, right? And that 50 that's I can actually receive 50 USDC, and that 50 USDC worth $50, right? So it helps cross-border payment. So among a lot of use cases why cryptocurrency and tokens, the use cases of cryptocurrency and tokens, right? So let's just move quickly to creating a cryptocurrency, a token, yeah, a cryptocurrency, right? Let me use.
So you're going to deploy a token on the blockchain.
Exactly. So, yeah. So first, before I go into, let me explain some key concepts, right, about what I'm about to do. First, I will talk about the blockchain. So first, we need a blockchain to deploy on, right? We need to interact with a particular blockchain. So what blockchain are we trying to interact with? You're trying to interact with a public blockchain. What's public blockchain? We're trying to interact with, so we'll be doing this on Ethereum blockchain, right? We'll be doing this on Ethereum blockchain, or better still. So let me divert a little here. So we're doing this on Ethereum blockchain, and on Ethereum blockchain also we have another blockchain called NAMI, right? So there's also a blockchain called NAMI. So what will be happening here is that we'll be deploying an ERC20 token on NAMI. Are we together?
NAMI is the public blockchain.
NAMI is also a public blockchain. So you can also check out NAMI here. It's also a public blockchain.
Like
so I just want to expand. Yeah, I also want to expand your understanding. So I don't really just talk about Ethereum. So NAMI is an equivalent of Ethereum blockchain.
So like this is a layer 2 blockchain.
Exactly. So this is a layer 2 blockchain. So maybe in another, I don't know if you guys have treated that. Maybe in another class, or we talk about layer 2 blockchains and what are the use cases, why are layer 2 there, and etc. I don't know if you have done that. So, but what I want you guys to understand here, I'm just trying to bring in this also part because this is also another knowledge you should have, right? So I'm talking about whether NAMI is a layer 2 or not. So I'll just be talking about NAMI is a blockchain, right? So we'll be building this on the network NAMI. So NAMI has a public network. I mean, a testnet network. So why do we need a testnet network, right? To build. So because we understand that smart contract is immutable, that we can actually make changes to them after deployment. So we don't want to build something and test it anyhow, or we want to find a better way where when we build, we have a sandbox system where you want to test out every scenarios, your functions. You want to make sure that what you have written, the code you have written works exactly the way it should work on mainnet, right? So there's a system, there's a testnet system that is equivalent to the mainnet. right? That is also being built
Oh,
in
is
this
Nami
net.
testnet like there is already existence testnet like uh, Cropstone or Borelli. So is this similar kind of thing, Nami?
Yes. So Nami is a blockchain, right? So it also has its mainnet and it also has its testnet. The mainnet is out there, right? It also has its mainnet. It also has the testnet. So for the testnet, that is where you kind of test your smart contract, right? So in testing your smart
Okay.
contract, you need some testnet tokens to be able to test out the smart contract, right? In that environment. So you just see that as a complete equivalent of the mainnet um, system. So for you to be able to do that, you need a testnet token, right? We'll be going into that aspect too. Um,
Yep.
so you need
Like
a
we will
testnet
talk
token.
about like Nami blockchain after the meet definitely. So I'm really
Yeah.
excited to
So
learn about Nami blockchain.
yeah, we'll talk about that. But what we're just trying to do here is to build a token.
Yep.
Are we together?
Yes, sir.
Yeah. So we're building that on a blockchain. And what blockchain are we building on? We're building that on a NAMI testnet blockchain. So firstly, what do we want to do? We want to write our code, right? So in writing our code, right? So because this is just for a very quick demo, right? I'll be using a library, right? Called the Open Zebelin library, right? What this library helps me to do is that it has written out the basic logic I need when I'm writing my ERC20 token, right? So at this moment here, you can see me. I'm currently using an a framework called the Wizard, the Open Zebulon Wizard, which like in a very quick jiffy deploys gives me like a click where I could just deploy or write a token. So what I'm doing now is that I'll just let me do 3 million. It's 3 million. Yeah, this 3 million. So copy this and so I'm deploying. I'm trying to now. Um, I mean, I guess my network is still there.
I think it's already compiled.
You said?
I think the contract has been compiled.
No, it's not compiling. I don't know. Let me try this guy here. Okay, yeah. So now contract. So I believe also you guys have done like how contracts are being like how when you write a contract, the next thing happens is that it's being compiled, right, to what the EVM, right, what the virtual machine understands. Then, right, I don't know. Anand, have you guys gone through that route?
The EVM part.
Yes, like how your smart
No,
contract
we
works, how your smart contract works on the EVM.
no, we couldn't cover this part. But
Okay,
definitely later after this session we will cover, or maybe you will cover.
okay, okay, okay. So for this lesson, actually, let us focus on these key points here. So
Yep.
yeah,
So,
we have our code written out now, right? Let me just make it public. So we have our code written out here. So in this code, what I'm trying to do is that I'm actually importing. Okay, let me just make this public. I'll not import this guy for now. And so I'm deploying an ERTJ token. I'll be calling this token, what should I call it? What's the name of your school again? What's the name of the school again?
IIT BHILAI.
Is it
IIT.
IIT, right? So that's what I'll be
Yeah,
calling
that's
this.
it.
Okay. So I'll be deploying 3 million tokens. That's what I'm deploying now, right? So I'm sorry, not deploying. I'll be minting. So when I'm deploying, at the same time that I'm deploying it, I'll be minting 3 million tokens to my wallet, right? So you can also set your own addresses and maybe share it on the chat. I will send, after deployment, I'll be sending some IIT tokens to you, and I will show you where you would go. So you also see that in your MetaMask wallet once you import it. So yeah. So for us to do that, we need to connect to a blockchain, and which we said we'll be connecting to. We're connecting to a testnet NAMI network blockchain. So let me get that. Okay. I guess this part of the NAMI is actually not been active now. So
So what is the consensus mechanism of the NAMI blockchain?
yes, the consensus mechanism is also proof of stake.
Okay, proof of stake.
Okay, so I guess something is at this point now. I don't want to take us through that route, this route of, because I guess something is breaking here. So what will happen is let's use another blockchain, right? So let's use another blockchain, and let's use the Ethereum testnet blockchain, which is Sapolia. So we have the Sapolia testnet blockchain. So we're using that. That's the blockchain we'll be using, the Sapolia testnet blockchain. So I'll be connecting I'll be deploying the token to that blockchain. So I click on deploy, I'll just do this, and so it's being mined. The transaction is being mined. So yeah, this is the explorer of the blockchain, right? So let me share that explorer with you. Yeah. So at this moment now, it's been mined, and it's mined. That has been mined. So so let's see. So I have deployed this token, and I minted 3 million tokens to my address. So what I need now is to copy this address, come to my MetaMask, and I want to import. So you also do the same process. You come to your MetaMask, come to Sapolia, make sure you're on Sapolia network, testnet network, and you come down here, import token, you paste in this address I'll be sharing with you, and you add custom token. So you notice now I have 3 million IIT token, right? And let me share that with you. So anybody that needs, just for demonstration, you can also share with me your MetaMask address. I'll share some token, or I'll mint some tokens to you right now. And once you import this token to your address,